From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Thank you very much. Thank you for joining us to this talk called Security Kubernetes Clusters from Access Control to System Hardening. My name is Rafiq. I've been in the IT industry for the last 15 years. You have my GitHub, my LinkedIn, and my email. And I'm focusing mainly on cloud security, cloud native security, including Kubernetes. I will let my friend Mohammed introduce himself.
Hey everyone, I'm Mohammed Rafraf, a platform engineer at Kubernetes. Also, I'm working remotely from Tunisia, and actually I'm interested in Linux, Kubernetes, networking, and virtualization. And also I'm a CTF player and challenge author, specifically in digital forensics. I will give word to my friend Rafiq.
Thank you. So we have a package agenda for today. We start by discussing why Kubernetes is a target. What's the factors that make Kubernetes a target for attackers and for bad actors. Then we go a little bit dive into anatomy of a cloud native application, understanding the different building blocks, and we start looking after the security by looking after the access control network security to follow up with node hardening and unique security layers. And by the end, we'll be talking about both sandboxing workloads to protect them and observing the workload in production using runtime security. So why Kubernetes is a target? If I take the Red Hat Kubernetes adoption report for 2024, you can see that 90% of people that are managing Kubernetes, whether they are platform engineer, security engineer, whatever, they experienced at least one incident in production. So this is like a very attractive target for attackers, and this is coming from different angles. The first thing that the containerized app still very young, so there is some security patterns that are not fully implemented or not implemented in the right way. We also have inside Kubernetes environment like secrets and others. We have also the architecture of Kubernetes that is based on universal control plan. That means if you take the control plan, you control everything. And also the way that you have gateways and open to the internet, Kubernetes cluster exposed publicly that can be reachable very easy or searchable very easy. That's the factor that make attackers prefer Kubernetes, and then they will do a lateral movement from there. If we look at the anatomy of cloud native application, the most important would be the workload. It should be like VMs if you are just doing shift and leave, some containerized app, maybe serverless if you are more advanced in your journey. And all of these, either they are running on top of a Kubernetes managed or non-managed platform or container as a service. And we have what we call it satellite service, like data management, identity, network, and security. And if you look at the picture like this, it looks quite simple. But if you go deep dive a little bit, and I borrowed this nice diagram from kubesecdiagram.github.io, and explain a different attack path and different entry point interaction within the Kubernetes ecosystem that make it is really very attractive for attacker and very easy to break. So one thing that I would like to mention, this is a good phrase that I borrowed from Jordan Bear, who is a Microsoft security researcher. He's saying defender think in a list, attacker think in graphs. As long as this is true, attacker need. That means you have to think about your Kubernetes deployment as a list of data flow and a list of building blocks, that each building blocks will have its entry point, out point. You have also the interaction, the permission, and this is the way that you need to think about it and try to secure every part of it. And the most common that we are seeing actually on the market, it's anything around identity and access, whatever. It's like an excessive identity that allow you to go inside the cluster and then inside the node and maybe do a lateral movement to your cloud account. Also dashboard misconfiguration, that's very, very famous, making a lot of noise. Malicious containers that are running with a known CVE like RCE or something that allow you to break into the system. And finally, also people that deploy secrets within their Kubernetes and as well Docker daemon misconfiguration, which can enable you to deploy containers without directly with hooking into the Docker sockets. That's the most important common attack. So within that, I will give the mic to my friend Mohammed. He will go through the access control and network security and later into the system hardening Yes, go ahead, please.
Thank you, Rafiq. So we will start talking about access control and network security. So starting with RBAC in Kubernetes. I know many of you already worked with RBAC in Kubernetes, but the main reason I want to bring this up again is simple. Most of Kubernetes security issues still come from misconfiguration in RBAC, and the challenge grows even more at scale when you are managing hundreds of roles across multiple clusters, and you will have a lot of users and a lot of applications deleted and added, so the mistake will be inevitable. So in order to enhance your Kubernetes security, we need to avoid some RBAC issue, and comes down to 4 things. So firstly, list a privilege, only give user or a service the exact permission they need. If you will add more permission, the attacker can escalate quickly, use these extra permissions. Also, we need to rely on namespaces. Namespaces are not just for organization stuff, they are also considered as a security boundary. And by isolating your workload, you prevent attacker from jumping from one application into another. Also, you need to review your configuration from time to time. We know that the Kubernetes environment is dynamic and we will have a lot of permission that will be changed all the time. We will have new application and old ones, and definitely you will find some old configuration are alive in your cluster. And it will be great if you delete them and clean them up. Otherwise, they will be considered as a backdoor in your cluster, since they can be used in a malicious way. Also, you need to audit on monitoring your RBAC actions. Actually, tracking your RBAC actions will help you to detect the misconfiguration, the misuse, even the attacks. If you don't watch anything, you will not detect anything. Moving to authentication in Kubernetes. Who are you? Before Kubernetes detect, or let's say before Kubernetes can decide what the user is allowed to do, it needs to know who the user is. And Kubernetes actually supports multiple strategies in authentication, and it's very important to understand which one are secure and scalable for real environment. And as we can see, we have many options here, like static tokens, we have TLS client certification, OpenID Connect, webhook token authentication, and cloud provider IAM integration. But in practice, the most common ones are static token and certification for simple setups, and OpenID Connect for scalable enterprise-grade environment. So we need to compare now OpenID Connect and TLS certifications. So basically using static kubeconfig with tokens or certificate might work for small tests, but they are risky in real environment because they are not exposed easily. They take time. So if you have a kubeconfig exposed or leaked, the attacker can have access to your environment for a long time. And also it will be hard to rotate the certification or revoking them. Meanwhile, in OpenID Connect, your Kubernetes cluster will be connected to your best or your favorite identity provider like Google or GitHub. And also the session will be short-lived and easy to revoke and tie it to your company's user's account. Also, maybe you will get some supports security features like SSO, MFA. And in short, I think OpenID Connect is the best way, or is the right choice for protection environment. So this is why we will introduce DEX as an OpenID solution, OpenID Connect solution. Why we will use it? Because it's simple, lightweight, open source. Also, it fits perfectly with Kubernetes ecosystem and easy to configure and deploy. But we need to mention that DEX, it's not trying to replace your favorite identity provider, just it will act as a bridge or translator between Kubernetes and your identity provider. So here, let's see how the Kubernetes authentication flow with DEX is working. So firstly, I will use kubectl with a specific plugin like kubelogin in order to trigger the authentication process. And DEX will redirect me to GitHub in order to finish the authentication process. Once GitHub validates me, DEX will issue a token and will give it back to me. So every single API request that I will send now to the Kube API server, it will include this token. So when I was trying, for example, to run kubectl, get money, the API server will try to validate my token. If DEX validated, I will do whatever I want based on my permission. Otherwise, I will get rejected. So this is an overview of how can we configure OpenID Connect. So firstly, we start with our kubeconfig. We need to configure it and add the necessary parameter for DIX in order to make our kubectl knows where the authentication process is. We have, for example, here the issuer URL. We have also client ID, client secret, and so on. The same for Kube API server. We need also to configure it in order to make our cluster able to validate the token with DEX. So we are adding also the same parameters, but this time in the CLI of Kube API server. On the other side, we have DEX. It's split it into two major parts. We have the connector and the static client. For the static client, we will specify the ID, name, secrets, and they will be used by kubectl and Kube API server. And for the connector, it's like specifying your identity provider configuration, and the connector will let know DIX how to deal or talk with your identity provider. So after making our RBAC secure and authentication is working correctly, now we need to talk about Kubernetes network policy. Basically, by default in Kubernetes, all the pods can communicate with each other without any restriction. Even if they are not on the same namespace, it's completely a flat network. It might be convenient for most of you, but from security perspective, this is bad. Because if an attacker compromised one application in a pod, he can communicate easily with all the entire services in your cluster without any problem. So this is why network policy is not an option, and it let us now define who can talk to who. So in this example, as you can see, that we have database pod that everyone can reach it and read the data from it. And with a tiny example here, we can restrict this access and make only the backend with the same namespace can access to it. And with this example, as we can see now, the database only trusts traffic from the backend. And this is called as principle of the least privilege in our network layer. And when it comes to network policy and the best practice, it's always recommended to start with default deny. You need just to block everything for the first time and allow some minimal communication, and then don't forget to apply some namespaces isolation to avoid communication across multiple namespaces if not needed. Also, finally, it's recommended to do some egress rules to restrict external traffic, because it's very important imagining that our application is compromised, so the attacker can download some external stuff like malicious script and so on. So this is why we need to block some egress traffic. So moving to securing network traffic with MTLS in Kubernetes. So MTLS or mutable TLS is how we secure communication between our services in our Kubernetes cluster. Only with the normal TLS, only the server proves who it is with MTLS. But with the MTLS, both sides, the client and the server, authenticate to each other. So no pod can pretend to be it's not. All the traffic also, it should be encrypted, which means that if someone is trying to sniff it to your Kubernetes network, he cannot read anything. So how the MTLS it works? Mutable MTLS requires both client and server to prove their identity through a certificate exchange. So the handshake begins with the client initiate the connection, and as you can see, the server sends the TLS certification to prove its identity, and on the other side, the clients will try to verify it with a certified authority. Next, the client will do the same as the service by presenting its TLS certification, and the server also will try to prove or check the identity of the client. And once everything is verified, the client and the service can exchange encrypted information securely. So we will try now to introduce Istio. With Istio, you can enable MTLS easily in your cluster. The traffic will be encrypted automatically without need to change anything in your code. Also, every single service will get its own identity, so no one can fake it. Also, additionally, we can control policies on the service or namespace level. And for certified authority, you will see that everything will be managed automatically for the TLS certification, rotation, and renewal. So how does Istio work? So with Istio, every service gets its own identity through STOD or the control plane. We have also Envoy sidecars handling all the communication between services. It will be deployed as a sidecar for every single service. It will ensure the encryption and validating the identity for every single service. And also, we don't need to have changing anything on the application side. Authorization, how to secure your application with authorization policies. So authorization policy in Istio defines what actions a service is allowed to perform in another service. In this example, as you can see, we have a service A is trying to get a request to the endpoint user and successfully get the response, but on the other side, service B cannot do it. So this is what authorization policy can do in Istio by restricting some path or some endpoint for a specific application. So this is an overview on the configuration, how it could happen. As you can see, enabling MTLS authentication it's very easy. Just you need to select the mode and also specify the namespace. And if you want to install it in cluster-wide, you need just to specify the namespace of the Istio system. On the other side, we have authorization policy example. As you can see, we can select the application that we want. We have the action, and we can define our rules, for example, by selecting the service accounts for our services and mentioning the operations that we want to allow or to restrict it. Moving to the system hardening and Linux security layer, we will talk about how to secure our cluster and make it as a jail if our attacker figure out how to compromise our application. So starting why not security is matter. Actually, we are running our own workload and pods in our node, so this is why it's important. So if it's compromised or it's owned, we can see that the attacker actually is owned the whole cluster. So it can steal your secrets, he can kill your workloads, deploying his own application and using it as a free infrastructure. So one vulnerability can risk everything. Starting with the base OS hardening. So for the base operating system, the key is to reduce the attack surface. We use a minimal Linux designed for containers, removing unnecessary packages, keep kernel and system packages up to date, disable SSH if it's not required, and restrict the specific admin's IPs. Also, we need to turn off some, or let's say any services not used in Kubernetes context. Moving to the Linux user and access control. When it comes to access control, each admin should have its own or their own account, just to avoid shared root logins, because it will help us in the future for investigations. Also, having sensitive directory like Kubernetes configs must have strict permissions. We also harden the kernel using the sysctl command. And regarding the authentication, it's recommended to disable the password-based and use SSH key or certification. And on the other side, it's also recommended to restrict sudo access to the minimal set of users. Kubelet hardening. We know that kubelet is running on all our Kubernetes nodes and it's acting as a Kubernetes agent. So securing it is very crucial. So it's recommended to start turning off the anonymous authentication in order to make sure that every guy is trying to authenticate to our kubelet to have an identity. Also, it would be great to enable the webhook authorization. So all requests are checked against the API server's RBAC. And also we can restrict API access by disabling the read-only port in order to make sure that no one can read our API objects. Also, we can let our kubelet manage its own TLS certification by enabling the flag rotate certificates to make sure everything gets done automatically. Beyond RBAC and network security, Kubernetes security also depends on the underlying Linux kernel. So features like AppArmor, security enhanced Linux, and seccomp provide process level isolation. Together, they limit what container can do even if it's compromised. So this will turn out our workload into jail, even if the attacker have access, cannot do anything you want. So starting with the AppArmor, so restricting file and capabilities. Armor is a Linux security model that runs in the kernel and provides mandatory access controls for processes. And also it uses profiles to define what a process or container can access, including file, networks, and system capabilities. Before the profile can be used, it must be loaded in your nodes, and it will be easy to use it in Kubernetes context thanks to the security context in our pod specification. So this is an example how can we use AppArmor in Kubernetes. So first we need to have access to our node. As we can see, we have a command that help us to list the loaded profile in AppArmor. It's AA status. In this example, we are creating a custom profile for Nginx application. As you can see, just it's a normal file when we define or allowing read access for the default Nginx path and giving some permission for network operations and denying everything else by default. And in order to load this profile in our node, just we can use the CLI AppArmor parser in order to make it loaded, and we can list again our loaded profile to make sure if this profile is loaded or not. And in the example, when we are providing a pod of Nginx secured, you can see how can we use this profile. So thanks again to the security context, just you need to specify the type of it. It's a local host living in our node, and then mentioning the profile name. Moving to the seccomp, just to limit syscalls for our containers or applications. Seccomp is a security feature in Linux that controls which system calls a process is allowed to use. So with this feature, we can actually define what kind of syscalls can be used by our application and which one is blocked. And also it relies on something called the seccomp's profile, which is a JSON file that can be hosted in our nodes, and we can define whatever we want. So this is an example of a seccomp profile structure. So the most important field in this file is default action, which decide what happens if syscall is not listed. Usually we set it to block with an error, which means that if we have a syscall, it's not listed in our file, we block it with sending an error to the application. Also, we have architectures when we specify our CPU architecture, and next, as you can see, we have syscalls. When we specify the list of syscalls that we want to allow for our profile, and also we can blocking others. And this is an example of how to use seccomp and profile in Kubernetes. Firstly, we create another seccomp profile as an example. It will be used for Nginx app. So we believe this is the list of the seccalls that will be needed for Nginx to work up and running without any issue. So we save it under /var libkubelet seccomp profiles, and then we can use it easily in our manifest or deployment, again, thanks to the security context. Linux capability are important. So Linux capability are like breaking roots for root power into small pieces or small keys instead of giving for root access or for root power. The system hands out the capability like managing the network, changing the time for your system, or loading kernel models. So containers start with a set of this default. Set up by default, which is not good because there is a lot of capability that are not needed at all. So why should we drop Linux capability? Dropping them is about reducing risk. By default, containers have power they don't really need. Attackers can use this power in order to escalate quickly and do whatever they want with our system. So removing them will limit the attacker and he will try to be in jail without doing anything risky. And this is how can we drop capability in Kubernetes. So it's recommended to drop all the capability by mentioning all and start adding capability one by one, and just it's recommended to keep it minimal. As you can see in the example, we have web apps, which is usually use NetBind servers. This capability used for just binding power for your server, and combining Linux capability dropping with seccomp and AppArmor will make our system or our Kubernetes cluster in a safe way. Even our application is vulnerable or the attacker compromised our application. And finally, mentioning immutable infrastructure here. So immutable infrastructure means we prepare everything ahead of time. So we install everything we need, packages and files, binaries. Then it's recommended also to configure your system before finishing the build. And also it will be fine to delete all unnecessary packages or binary like curl, wget, netcat, or even the package manager in order to make the attacker unable to install anything or importing anything from the external world. Once it's deployed, it will be nice to consider the nodes as immutable, so we cannot change anything or make any fixes. If you want to update a package or removing something, we need to build another OS image or not image again. And I will pass it to Rafik again to talk about sandboxing workloads.
Thank you, Mohammed. So when it comes to sandboxing, we need to understand how containers are working under the hood. And by the end, the container is a process that is making system code. So he's talking to the host, he's talking to the kernel, and he's isolated with Linux namespaces and C groups. But we need another layer in the middle. And this layer will be doing two things. The first thing is filtering what is coming and blocking the one that we don't want to come to the kernel. So the first risk that we have here that it's the host is shared between different containers, so we can have a container escape attack. Also, if I have a container that is super powerful and we don't have the sandboxing, I can exploit like kernel bugs, misconfiguration, or any privileges, and I can run a lateral movement and compromise the cluster. So what we need to keep about sandboxing, it's an extra layer of isolation when we have like another boundary beyond namespaces, Linux namespaces, and C groups. In terms of Kubernetes, it comes as black box between containers app and the host kernel. And as I mentioned, it's to protect against system syscall exploitation and kernel 0 days. And we need to keep in mind that this is not a replacement of any other security feature like seccomp, AppArmor capabilities that Mohammed exposed, but it's complementing in terms of monitoring and blocking and allowing system calls. So in terms of technology, we have two main, technology. Kata Containers and gVisor that come with different design architecture. Kata Container, on one hand, they are focusing on having micro VM. They are super isolated. So the container will have its own hardware, where gVisor is adding a loader layer between the kernel and the container. So in terms of choice, I would say gVisor is more lightweight. So you can go in less restricted environment. But if you have a very restricted environment, whatever, like very trusted workload for government, for financial services, it will worth like to implement the Kata container. So how it works, for example, here with gVisor, we need to install gVisor with the Kubernetes within all the nodes that we wanted to run gVisor. We can select a subset of nodes that we can like taint some nodes and tell this is 5 nodes that will be running high confidential workloads with gVisor. And then we have to add to the Kubernetes object at the second step, defining the runtime class, and then using the runtime class in when I'm creating a container, I will tell please use the gVisor one instead of the Kubernetes default runtime, which is ContainerD, for example, by default. The sandboxing limitation, as I mentioned, the performance side, you need to take this in consideration because you are adding an extra block. You are filtering system calls, so it will add latency. That's why you need to decide if you go either with gVisor or Kata container, or just keeping like the ContainerD as is. Also, there is some compatibility issue when it comes like to system calls, supported file system access, and so on. And my final takeaway is, just use it for a very selective use case, which is high risk workloads that like PII data or whatever. When it comes to runtime security, it's very important. If I go back to the Red Hat report, you can see that people observed 45% of security incident during the time and come just before like having a vulnerable application. So this is a really part of your process or workflow, because even if you are applying DevSecOps, you still have to monitor what is happening in the runtime. So here we are just giving one example with Falco, and the way that Falco is doing is actually ingesting any system calls for containers, plus ingesting any other logs from Kubernetes, whatever it's Kubernetes audit logs, cloud logs, GitHub's Okta, and building a set of rules on top of that and set of policy. And whenever something happens, it will get triggered and send it to any notification channel, whatever it's Slack, Elasticsearch, your page duty, and so on. So here, in terms of workloads, we are copying the system calls. Either we are using a kernel model or we are using a BPF probe, which is less intrusive. And from there, we have the ring buffer. And on the ring buffer, we are reading the events. We are comparing those events of the list of the rules or policy that we defined. And if there is something that is matching, we raise an alert. So this is the way that that is working. For example, here I have an example of someone who is just hooking inside a container. So you can see that we have the rule name description, the condition, where should I raise this event, and the output that will be showing up to the platform engineer, security engineer when something happens. So we also have like a list of other objects that we can use to make the rule readable, like list and macros. And by the end, when something happens, you get like a notice or a warning, depending on the rule that you have defined, and you can take this either to your SIEM solution or you can treat it locally. That's the way that we are doing actually runtime security. And the good pattern with this, that you can, because you are running here with the kernel namespace, if there is something happening, you can stop the attack immediately, versus if you are taking logs from Kubernetes cloud trace and so on, the event is already executed, so you cannot roll back. But on the system kernel here, you can take a decision and say, oh, I don't want to run that system call. That's all from us today. Just a recap here about the different, let's say, building blocks, the checklist that you have to have. Otherwise, I was mentioning that you don't want to have checklist, but that's like the building blocks. And you can start from top to bottom or from bottom to top. That's up at your use cases. So thank you very much for joining us today, and any question is welcome. Thank you. We have a couple. Oh, why Istio? Yeah, that's we were expecting that question. So it's depending. If you can go with Cilium, you can go with Calico, whatever your use cases. I would say, yeah, just we show an example with Istio, but it's not like something more powerful than the others. Maybe Istio is either for more like advanced capability that you may not need at some stage of the project of your like platform. So you can start like with Cilium, with any other like. Networking and MTLS tool that you can use it, but yeah, it's not an. We are not saying Istio is the best. Okay, what authentication flow and condition do you recommend for machine like CI/CD? I will let you Mohammed answer this.
So basically, for automated workflow like CI/CDs or working with service accounts, it's still recommended just to use tokens, static tokens, because this is the only way to make it easier for us to make automated workflows.
Okay, are there some out-of-the-box tools or solution for node and port hardening, Mohammed?
Okay, there is some tools that we can use just to scan our configuration and see what's the best practices that we are missing in our setup. And they are open source, and we didn't mention them because just we are trying to suggest our approach.
Okay, so do you recommend Istio? As I mentioned, if you have like any other tool that support the use case, start with that. Don't add any additional tools. Yeah, that's my recommendation. Do you forget to enforce with least privilege security standard admission controller? That's a good question. Yeah, that's something. Yeah, that's something you can apply. Usually the teams, they don't apply the admission control at the beginning. Otherwise, you will be pushing like 90% of your workload to be deployed. And even sometimes business owner that we take the risk to deploy like a misconfigured or like a vulnerable application over stopping an application to run in production. So this came, I would say, or more mature team that been implementing security, whatever, in terms of like best practices, hardening, vulnerability management, runtime, threat detection and response. And usually the team, they start like doing this after 2-3 years. They don't enable immediately admission controller. Otherwise, if you are working for a big organization where you have like thousands of developers, it will be a big mess. Okay. Which building blocks would you prioritize? If you have workloads in production, start with the runtime security. If you don't have workloads in production, start with the DevSecOps process, implementing the best practices within your CI/CD pipeline, within your developer workstation, and then move to production. But if you have already workloads in production, you need to start monitoring what's happening in the runtime. Why not just use Talos for Kubernetes security?
Okay, we already mentioned in the OS hardening, we recommend to use the minimal OS that are ready for running containers only. We didn't mention any kind of examples here, but yeah, you can use Talos. It's recommended. I am not against any other tool. And for why not just use in the example here, security enhanced Linux too. Actually, I'm a Debian guy, and most of the system are relying on Ubuntu and Debian servers, so this is why I didn't mention Red Hat as an example. And that's it.
Thank you very much, guys. Thank you. Oh, yeah, we got one more. Gatekeeper. What do you think, Mohammed?
Yeah, it's an open source and famous tool, but I'm seeing a lot of people now love Keyverno more than Gatekeeper. But yeah, we can use any policy engine you want and you feel comfortable with it. Even I think there is another one called PolicyGS from Loft Labs. It's only a nice one, just if you want to define your policies using a programming language.
So that one is much easier to use, right?
Depends on the person. Sometimes people hate YAML files. Sometimes want some people to write some with programming language. But yeah, I still recommend Gatekeeper.
Okay. Nice. Thank you very much, guys. See you around.
Thank you so much to our speakers. One big round of applause. And we will continue in a few minutes with our last talk for today.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.